Lesson 24, Pressure. Our objectives for this lesson are first to define pressure. You'll also want to be able to recognize and utilize pressure units. One of the things that you'll notice is that pressure, much like speed, is used a lot in everyday life. And every time it has a different use, it gets a different unit. So you want to make sure you're using the correct unit. Lastly, you want to be able to solve using the pressure equation. So let's start with the definition. We know from our study of forces that forces can be applied to an object, but we never talked about how they were applied to the object. And that's what pressure deals with. When a force is applied to an object, it's done so over some amount of area. So whether that force is spread out or whether that force is concentrated is what pressure refers to. So we can think of it as the concentration of the force. The precise definition is the ratio of how much force to how much area. Now, that definition is going to give us our formula. So before we get to the formula, we need a symbol. And our symbol for pressure is a capital letter P. And since pressure then is a ratio, it's going to be a fraction. In this case, a fraction because it's a ratio of force to area, so F over A. Since we have these three things in this formula, we're going to want to put it into a triangle. And this triangle is actually going to be very useful because a lot of times you're going to be solving not just for pressure, but for the force or for the area. Now, one thing to notice about this fraction is that the smaller the area gets, the larger the pressure becomes. Or we could reverse that. The larger the area, the smaller the fraction. So the smaller the pressure becomes. So the smaller the area, the greater the pressure. The larger the area, the less the pressure. Now let's take a look at some units. Our basic unit of pressure that we are going to be using mostly comes right from the formula. Force is measured in newtons, and the area is going to be measured in square meters. Much like other units that you've seen, for example, the joule, which is made up of a newton and a meter, called a newton meter, and power, newton per meter gets another name. In this case, it's called a Pascal. It's named after a scientist named Blaise Pascal who did a lot of work with pressure. One of the things to note about this particular unit is the abbreviation, and that is that a Pascal is abbreviated with two letters, PA. In the British system, we measure force in pounds and area in square inches. So we get a pound per square inch, which is sometimes abbreviated as PSI. Now, one thing to note about a Pascal and a pound per square inch is, and we talked about this on the previous slide, the area. A square meter is almost like having a square yard. A square inch is significantly smaller. So the numbers that you're going to get for PSI, or pounds per square inch, are going to be a lot smaller than the numbers that you're going to be getting for pascals, because a pascal is such a small unit because of the square meter. So for pascals, don't be surprised if you get very, very large answers. Now, another unit that you will probably see in everyday life is called inches of mercury. You might be thinking, how do we get inches? Well, when you watch the weather, they'll talk about the barometric pressure. Baro is a prefix which means pressure, metric, measure. So a barometer measures pressure. And the way that it measures pressure is by using a column of mercury. When the outside pressure pushes on that column of mercury, that column of mercury will rise or fall. And they measure the height of that column of mercury in inches. So when you're watching the weather and they talk about the barometric pressure and talk about it in inches, they're really talking about inches of mercury. Another one is called atmospheres. Right now, you're experiencing approximately 1 atmosphere of pressure. That is, the atmosphere around us is pulling down with pressure, and we're experiencing 1. The people who are usually concerned about atmospheres in terms of a unit are people who go skin diving or go below the surface of the ocean. Because what they want to do is they want to compare what they're feeling below the surface of the ocean as opposed to what you would feel just standing on the surface of the earth. We are mainly going to be using the first 2 units, a Newton per meter squared or Pascal, and pounds per square inch. These units can be a little bit confusing for students, especially because this is a time when we are definitely going to be using both British units and metric units. And also because the Newton per meter squared does get another name. So what I've done is I've given you each set of units on the triangle so you can see what you're going to get out when you're doing these problems. So my suggestion is that when you put the formula for pressure on your formula card under mechanics, you will also want to put these 2 triangles with the units so that you can keep them in line. Now let's take a look at an example. A person weighs 100 pounds. His foot has a surface area of 20 square inches. If he stands on 1 foot, how much pressure is he applying on the sole of his foot? So as usual, we start by identifying what it is we're looking for, the pressure. And we now put down our formula. Now remember, our formula can be our fraction, or it can be in the form of the triangle. In either case, we see that we need a force and we need an area. The force is the weight, 100 pounds. The area is the area of the sole of his foot, 20 square inches. So now we can substitute our values in. And by putting our units in, we can actually see what we're going to get out. So when we take 100 and divide by 20, we get 5. But right from our formula, we can see that we have pounds over square inches, and we end up with pounds per square inch. Or if you wanted to write that as PSI, you could. But there's our final answer. So you now have a definition for pressure. You've been introduced to some of the units, and you should be able to solve using the pressure equation.